getting started with PySplot. So for this, I'll be demonstrating the Mac version. So I assume you've downloaded the zip file, you've double-clicked it, and then you get this .app file. If you could install this or put this in your application folder if you wish, or you can just run it from wherever you stick it. Once it opens, you're gonna be greeted by this interface. There's a dialog at the top that is a prompt to interact with the application. There's the plot window, and then there's a list on the right of the spectra that you have open. So I'll go File, Open 1D Fits, and I'm on my desktop here. So I had this random spectrum here that is of a Wolf-Rayet star, and you can see it over here in the list. So you can actually open multiple spectra, which I guess I'll go ahead and do. Command open is the shortcut here. Oh, I don't have them in this folder. That's no problem. I go to where I have a couple others living. So if my brain remembers where I have things. It is in the Python. There it is, PySplot virtual. This is my working folder. So you can select more than one at a time. Now I've got 3 files open. If you want to look at the different ones, you can click on them, and then the corresponding one is plotted. You can see which one's plotted here. You also see there's a little number in front that corresponds to the number in the list. There is in the view menu a couple options. You can overplot spectra on top of each other. This isn't terribly useful if you don't have normalized spectra. And then there's stack plot, which again is not terribly useful if you don't have normalized spectra. This program can normalize spectra, but if you want to figure out how to do that, I can make another video if you'd like. So I'll just go back here to the one spectrum here. And I want to use the bisect feature because I believe that was what you were interested in. So you can define the region first, or you can just go to bisect and it will ask you to make a region. So at the top here, it says left click or the X button on a range of points. So here is a point, and I can remove that point by using right click if I didn't like that, or hit backspace. So something like that. Now, if I was just selecting the region, it would be done, but since I did the bisect, it automatically now takes me to the what height would you like to use? I actually don't like the way I selected this, so I'm gonna hit cancel. I'm gonna go to region, clear region, and please, and notice there are shortcut keys for a lot of things. Some have command in front of them, some don't. So again, I'll just go define region this time, and I'm gonna be a little more careful about how I'm clicking. The vertical doesn't matter because this only uses the horizontal position. And the way I wrote this routine for bisection is that within this region, it's looking for the left and the right half at whatever height you want to make the bisection measurement. So let's say 1.1. And it has plotted, and these are the matplotlib interactive buttons here. So these are handy. The way I've got it plotting, this is kind of gross looking, but you could go do another one, bisect again. It's still using that same region, so I could choose a different height, so 1.5, or whatever, and however many of these you want. Now let's say that you wanted to do this bisection on some other information. At the top here is that we're outputting the log to the desktop, and it's a comma separated value file, and this is the line that's in there. So it looks like gobbledygook here, but the bisected center is 5695.24 angstroms. And at the top is a slightly different number because we had a different height. So when I did mine, I did like 5 for every spectra and averaged. So everything that I'm measuring is being saved, so I don't have to like write these down or anything. Now, if I wanted to like apply this to a different what we could do is save the bisect region, the default name, and it is going to save in the last folder it opened apparently. So I'm going to put that on the desktop instead. There we go. And what else am I going to do? I'm going to show you that, well, if I wanted, I could actually measure everything in the stack here. So all the stack operations are in the stack menu, and there are some things that are maybe self-explanatory, maybe not. But as far as bisection goes, we're going to go down here to the bisect option, and it realizes that we haven't gotten a region. So if I'd already had the region selected and I already had the height, then we'd be good. But I think I cleared that when I saved it. So I'm going to define the region. Again, the vertical part doesn't matter. Let's do 1.3. So in the log, I know which one came from this. And when I hit OK, it's going to do this on every spectrum that's in the stack. I have tried this for up to like maybe 50 spectra in a stack. I'm not sure how reliable it would, or how rather quick it would be beyond that. And there it's done. And so it says at the top, stack operation complete. In the stack mode, it doesn't plot that horizontal line. So maybe play around with it on a few individual spectra and then apply it to a stack if that's what you're planning to do. When you're done, yeah, what you should do if you want your log file to save correctly, I think this is a bug I haven't quite worked out. You should close all spectra, or that isn't necessary, but you should quit with this quit button and not the red X, because the red X basically terminates all execution of the code. And I'm not sure if I fixed that particular feature or not. But to be on the safe side, you should quit it this way, and it will save the log. So what I want to do, just open up a text editor here. I like Atom, so that's what I'm opening. All right, so I'm with these 2 files. I'll just drag them in here. So that bisect par, this top line is the file that I had open when I saved it. This is not actually terribly useful. So you can actually, this line needs to be there, but it doesn't matter what's in this line, because when you open, or load rather, the bisect region, it does not read this line. All it needs are these 2 numbers. And you can define, so there when I saved it, I was running it at 1.5 for the height. So if you wanted to have very specific left and right positions, coordinates, you could do that. And so you could do this and that, I guess, if you wanted. And again, for bisect, it doesn't read the vertical height. So these have to be here because of the way the code reads this file, but again, it's ignoring this. And then 1.5 can be whatever you want. So you could make it 1.2 up and hit save. So what you can do is use one of these bisect parameter files and then load it later, and I'll show that in a second. And then the log file here has, it's all comma separated value, and it's label and then value. So the first thing is file name here, and then Julian date. Now my file obviously is missing the Julian date and the HJDs for whatever reason, and then obs date. And then whatever thing you're doing, my program does quite a few things, but in this case, the bisection. So the bisection center is here, followed by units. It also measures, or also records the height that we used, and puts its units. So when you open this like in Excel or something, you can quickly remove the columns you don't care about, like the labels or the unit, but all measurements you make are saved to one file, which is I have found pretty handy. So one more thing I'll show you is opening the PySplot one more time here. And I'll go File, Open, and I'll just open that same first spectrum again on the desktop. There it is. And this time region, I'm going to load the bisect region. So I'm just going to load that. And it will automatically go, hopefully, to what we set. And I forget exactly what we set. We could, of course, check. Yeah, so 5636.0 is, I think, what we set. So that seems to check out. And then I'm sure the other one checks out as well. And so it doesn't plot the height here, but if you run the bisect, it should just go. And it did. It just went without asking me for the height. So that's useful if you want to apply it to a stack as well as another method that I've used it for. So hopefully that gives you some idea of how to use my program. If you have any questions, I'm more than happy to help you.